Hello and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Today's webinar topic is solar panel recycling, and our presenter today is Curt Spivey, who I will introduce in a moment. We're going to have a Q&A session at the end of the presentation, so if you have a question or comment, you can use the Q&A feature located on your control panel on your screen. And please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And also please note that the Pennsylvania Recycling Market Center, its affiliates and funders, and the National Recycling Coalition assume no liability resulting from the use of any information provided during this webinar. The webinar is only provided as an informational tool, and no discrimination is intended and no endorsement by these organizations is implied. And now I'd like to introduce our presenter. Curt Spivey is the president and CEO of Cascade Eco Minerals, the leading specialty glass processor and newest division of industry giant Dilubic Glass. With over 25 years of experience in electronic processing and green technology, Curt has worked as an expert consultant for many nationwide recycling processors, as well as utilized his extensive engineering experience to design and install e-waste processing systems throughout the recycling industry. Curt's position with Cascade Eco Minerals has allowed him to advance the options for ethical processing within the solar industry by creating a unique remineralization and enrichment process that allows for a complete recycling of the solar module back into raw materials for manufacturing. So Curt is here with us. We have two videos here. Unfortunately, we can't get the audio to go with it. The first is a quick video clip talking about Cascade Eco Minerals, and it did come with audio, but I apologize. So we're going to run that, and then after the video clip, we have a PowerPoint again with audio embedded into the presentation. So again, we're not having that audio, but hopefully we can have Curt maybe work us along with this with these slides, and we'll get this information out to you. So, Curt, do you want to start off?
Yeah. Thank you, Wayne, for inviting me to present to your group. And yeah, it's unfortunate we lost the audio here, but once we get through the two, then open for questions, and there'll be a lot more information I can provide that is probably not seen in this in these presentations that I'll go on further and explain. So
well, let's run the clip. I'll be able to hear it, but you guys won't. I apologize.
Go ahead and go to the next slide. I guess it's pretty self-explanatory. Okay. Start off with the solar statistics. And you may have seen this if you're a member of SEIA, but solar ranks either first or second in capacity added to the U.S. Electronic grid. Solar energy accounts for 1.6% of the total U.S. Electricity generated today. American solar power offsets over 70 million metric tons of carbon dioxide every year, which is like planting almost 1.2 billion trees. That's their statistics. But one thing I could expound upon a little on this graph as it shows out to 2024. I believe that this growth will actually be larger than this that it's shown here, because of the turnover of solar due to the advanced rapid pace in technology. They're just rotating out panels that were built 5 years ago or obsolete, even though we might look at a solar panel and manufacturers will say that the product will last for 25 years, but yet it's just not working out that way. So next slide. Kind of went through the overview of our company without reading this verbatim. We've been in the industry processing glass for 80 years. And this happens to be an electronic device that's 80% glass. So, overall, it was a natural fit for products that we were processing already. We process more windshields, which if we look at the solar module is very, very similar in a laminate, and the way it's constructed is a windshield. But Cascade employs fully proprietary processes. Our systems that we've built are pretty extensive and automated, and we're it's kind of a natural fit, and we're kind of the perfect answer to the growth of this particular industry product. So let's go to the next one. And our locations keep expanding. Here we have we're building a plant in the Pacific Northwest. Our capacities continue to increase, and we're extending out to other electronic distributors and networking, throughout each state in the union to consolidate the production of from the production of solar throughout the country. And so anyway, here's our overall map. And so we start off in the stage of we'll get a load of solar panels in. We analyze them for any opportunities for reuse in secondary markets first, for refurbishment possibilities. And in many cases, our customers don't want their product set into secondary markets, but would rather have them assured destruction. So we offer both services. And then we process it back into a raw material. And overall, what we do mostly is we manufacture custom mineral compounds for our customers. They'll actually prescribe to us their mineral chemistry, because glass is a mineral. So when you look at different products that are made of glass, each of them have their own mineral chemistry. And we actually make the raw material mixtures for our customers. That's our focus. And we're also making now our own products from the glass, like glass beads. But we have a glass bead manufacturer in New York where glass beads are used in highway striping for reflectant and for signs and all kinds of things, and have been doing that for a while. And of course, we make the raw material compounds for making a number of different products like insulation and glass and new glass. Okay, next slide. So glass reformation, used in solar glass as a filler. We also take the metals and they go back into, you know, the metal market stream, aluminum. We're doing an interesting recovery of solar wafer and SIG because we get quite a bit of material from the factories that we work with here domestically, and we're doing a process to separate and process wafer and the wire as well. Next slide. Reuse is an interesting dynamic to opportunities, because we always believe the reuse is always the first step in recycling. And if there's an opportunity to use it, most of them, you know, will be sold into secondary markets for off-grid use. We also like to, with our glass, with regard to the circular economy, we're working with one of our largest customers to make solar glass or glass used in solar by consolidating a lot of our material from solar glass right back into making new glass for solar. So I'm working really hard at this, and it's one of the things our customers really would love to be able to tout in their own marketing for solar. Okay, next. Um, 70% of the material we receive is recycled, and 30% roughly is able to be reused. And the reuse thing is interesting too, because very similar to other products that we've all grown and seen in the electronic industry. Take, for example, the cathode ray tube, or CRT television, was a product in our country for 60 years. So it has 60-year legacy. And then in less than a 10-year period, it went from a CRT device to a rear projection device to an LCD, plasma, and LED. And so the legacy and the changes that we saw in those devices, as well as computers and phones and everything we've all seen in the last 10 to 15 years, you can say the same thing for solar. And so that's where there's such a high degree of turnover now, because of the amazing technology of solar in the last 5 years. You know, taking a 250 watt panel 5 years ago to almost a 500 watt panel today. So the technology curve is mirroring those of other products that we're used to using. Next. Again, the reuse market, manufacturers, not all, they don't want to see themselves, you know, competing with themselves in fear. So the secondary market for modules is there, but generally the panels don't carry the warranty, UL issues, with no warranty or labels. These panels are only to be sold into select markets with lesser value, which limits the large commercial sales and sales for those looking to use panels on the grid. But there's a lot of reuse in secondary panels from the standpoint of running pumps out on ranches and just a number of uses. solar panel demanufacturing provides a refurbishment option that can allow panels that are able to be repaired a second life, which is a goal that we strive and we're working and developing pretty rapidly. Next. The solar capacity. While many in the solar industry frantically search for recycling solutions they believe don't currently exist, the options have been available for some time. We have found PV solar product to be a net fit within our current operations. And what I mean by that is we've developed years ago, again, with windshields, and which is again very similar, and I'll go into further detail on that. Our extensive facilities are currently well prepared to handle a swell of solar panels reaching the end of their useful life, or as I say, because you can replace a 250 watt panel with a 500 watt panel. In 2019, we processed 500 million ton, or 100 billion pounds of material. So, but less than 5% of that was solar material. So to give you an idea of our capacity, and I know there's a lot of talk about and stress about what are we going to do with the giant wave of end of life solar. In our locations, we're ready for that volume increase. Our plant capacities are actually, as you can see, we have the capability of taking on any surge or tidal wave of this particular product. It just so happens that it's a fairly new industry as far as products go, and we're well prepared from a capacity standpoint to handle that wave. Next. Yeah, investments, separation technologies, and this is one of my most favorite areas to work in, is separation technologies and new possibilities for reuse. Cascade Eco Minerals is always working to improve separation technologies. We also believe the industry as a whole will need to continue to evaluating and creating new avenues for reuse materials and better support the circular economy. This again is where I'm spending a lot of time in connecting those dots with the remineralization and making new products. We have a couple new products we're bringing on, have been working on actually for over a decade, that I can explain to you later in the presentation. But fortunately, my partners, they own a factory, a gun factory, and they're able to we produce our own equipment to process, because processing glass is a highly abrasive material, and you can really go through equipment and wear items and parts, and being able to produce our own replacement parts for machines that we designed to do our processing keeps us going, and we don't have to wait for parts and things, and it's one of the areas that is our strength. So next. Solar panels are made to last for decades, so why plan now? This again, solar panels break. Others may have manufacturing defects causing them to reach their end of life earlier. We see a lot of storm damage. We see a lot of hurricanes, and we see a lot of hailstorm damage. And we work pretty closely on in that area. And so there has been a higher rate of turnover in the solar industry had anticipated due to the ramp up again of changes in technology. And we're going to continue to see that along with these natural disasters that happen every year. as this industry expands. They're often replacing, now we're finding replacing versions of their modules for newer, you take the same footprint and you double, you double your production. And I think a lot of the manufacturers are also working with their customers in the sales cycle, knowing that technology is just ramping faster than the modules can, last as far as utility installations and large commercial installations. So it's kind of it's a sales technique being employed by the manufacturers with their customers due to that ramp up in technology. Next. Solar and the Green New Deal. Now, solar already plays a large role in transition from fossil fuels. This is because of green legislation like the federal solar tax credit. This credit has made the solar a viable option for many Americans. Again, with technology, it's the return on investment with even the homeowner is dramatically changing and becoming more attractive. As the price of solar decreases, the demand for residential solar increases. This is because the residential solar places production in the hands of the consumer. And if this again, there's governmental incentive also within the industry to add to the natural growth of this product. Next. Why choosing a recycler matters. Solar recycling industry is relatively new, as I had mentioned before at this stage. Many companies choose a recycler with processes that simply strip away the metals and discard the glass. This generally means glass is sent to haz waste landfills or often places unknown. Glass comprises of 75 to 80% of the solar panel, which means an enormous amount of reusable material for us is being discarded unnecessarily. Cascade Eco Minerals provides a truly green recycling solution. I'm not trying to toot our horn, but I mean this particular electronic product, similar to the old CRT, it has a large percentage of glass, and that's our business. Our services ensure glass is reused back into new products, which aid for the growth of the circular economy and lessens the strain on the environment. Next. So questions. I mean, I kind of touched on quite a few things there, but I really am happy that Wayne invited and gave me the opportunity to talk a little bit about the solar industry and the fears that I think the industry has on how we're going to handle this large growth of waste in our streams here going forward. It was just a natural fit. And I explained a little bit earlier how we developed our separation and process. And it was largely through looking at the windshield that has a layer of polyvinyl urethane. And similar to a laminate from a solar panel or module, it has EVA, which is similar to polyvinyl urethane, and a back sheeting, and its makeup is very similar. So it was something that was a natural fit that we took on, and we added. Certainly, there's other separation processes in our system, but we're able to do high volume and recover just about 90% or 99% of the panel. And we have some interesting separation processes for that, down to the wire, and the hazardous nature of the panel is largely the tin lead coated wire and solder. And we've got a process for recovering all of that. I could go into more detail, but I'll wait for your questions.
Yep. And don't give away your trade secrets, Curt.
That's right.
So thanks, Curt, for that presentation. I did listen to the pre-recorded version of this presentation, and yours was better, by the way. So I think we're fortunate this glitch when happened here. But and thank you for the. I did get a tip here from an attendee on how to get that computer sound up. So thank you.
Okay.
But little bit too little, too late. So, but thank you for providing that information. So we do have time now for some questions. So if you have a question, use the dialog box on your control panel. We do have some questions up already, so I'm gonna get into that. So the first one here is, do you process the solar modules at every location in the United States?
We have we do process at probably half of them now. We do sub disassembly and processing at most all of them.
Okay.
But I'm focusing this solar material into just a couple plants because of what we're working, because it's its own mineral composition, and we want to keep it clean and virgin to be able to make new plate glass, solar glass, and we're working. So I'm trying to consolidate that material in 1 to 2 locations, so we can provide that raw material back to our customers to make that glass. So that's kind of our focus right now to meet the need on the circular economy, which has taken quite a while actually to do. But we're pretty excited about the results and what we're doing.
How does that compare to, like, I know, like for bottle glass recycling, a lot of times it's a regional issue of shipping cullet to a bottle plant. Is that the same issue you guys face with your operations?
Oh, sure. Yeah, absolutely. But, you know, as far as incoming goes, but as we process, you know, and make this back into a raw material and remineralize it, we have rail sites at each of our plants, and our customers, they don't just get a box here and a truckload here. They take train loads of material, and so we use rail quite a bit from that standpoint.
It's definitely more productive to do it that way than trucking.
Sure.
Yep. Yeah. So this question has to do with heavy metals. Since some solar panels contain heavy metals, how do you ensure that none of these metals are present in the products that are manufactured that you reclaim?
Well, what we found is that the heavy metals that are mentioned, you're talking about the wafer and the SIG, which is a copper, indium, gallium that you'll find sputtered in silver. And I've done a complete digestion with that material, and it's, quite frankly, everything I mentioned, there is a mineral, and it's at such angstroms measurements, small, that by the time it gets remineralized and made into a formulation for our customers, it's just not there. We do recover, again, most of the hazardous heavy metals that are mentioned there is the tin lead solder on the bus bar and wire that's in the solar cell area. So that is recovered and separated from everything else, and that's the true concern. But those heavy metals or metals concern is again, it's at such an angstrom level when it comes down to the remineralization processes that there's no level of concern.
Okay. Are all PV panels made of the same glass chemistry. How do you separate the panel with different chemistries?
It's all very, very similar, with the exception of one of our customers that does use a cadmium telluride coating on their glass, and they have their own leach aid process where they'll remove the cadtel from the glass and wash it and filter press that to recapture the cadmium and telluride, and then the glass, then we get that glass. That's the only differentiating, concern that we have on the solar.
When you calculate the greenhouse gas savings, are you taking in transportation into account for the used panels?
Well, I haven't done that calculation yet, to be quite frank. I mean,
Okay.
it's just, it's kind of a natural savings, just because we're consolidating the volume of this into one area, and transportation is generally, again, by rail. We do get, all of our raw material, broken panels and scrap panels and things from factories, that they all come across in trucking. But yeah, I can't say that I can give you a number and how we're calculating. It's just a natural, naturally we're going to be saving in that kind of greenhouse gas emissions.
I'm sure it's something EPA is looking at. I know their warm model folks are always looking at ways to add additional materials and different methodologies of calculating emission reduction. So I'm sure they're working on that. So yeah. How do your consumers access your services? Is this mainly done through the installers or through contractors, or is there a direct access there, or how does that work?
We work directly with a lot of factories and other electronic recyclers, a few of which are on the phone, and we're a downstream for their services as they scale out with customers. We are contacted directly by all the ones that you'd mentioned, distributors, a lot with the installer groups that work directly with those distributors. Anytime that there's a new installation and project, we get involved from the beginning, because there's always seems to be in a new installation, whether it's damage in transit or in installation, but about anywhere from 1% to 3% of an installation will have damage. Either they'll do something, over torque something and break the panels, and some of the panels are a little more fragile than a manufacturer's panels than others. Anyway, so that's generally where we see our materials. So we get them from everywhere, the utility companies, from installers, just people reach out to us directly and ask how they can, and then we'll contact one of our installer partners to help them. I'm actually, ironically, we're looking at a project in Pennsylvania right now that have some pretty old modules on their school. I guess there was a program 10 or 12 years ago that incentivized schools to have solar, and now I think they're removing them because they're low wattage, and so we kind of goes all around. They'll reach out to us for all kinds of different ways. That's where we get our material.
Okay, so a follow-up to that question, and this has to do with the legislation that's out there. I know some states have already passed some legislation or considering it. I know one is Pennsylvania. They've had several hearings recently on passing some laws to help solar panel recycling. What are your thoughts on legislation, and if there is legislation, what will be a model law for you to help make this industry grow even more?
Good question. I've in my years, I've been very, very involved in electronic recycling legislation, and being in the Pacific Northwest, or at least officed here, I've had the advantage of working with California's legislative body, where California uses a advanced recovery fee model. In Oregon and Washington, they've used a producer responsible legislative model. And now Minnesota is considering that, and Illinois and New Jersey and North Carolina, Pennsylvania. So similarly to the electronic industry, computers and televisions and what's currently out there in 28 other states, now solar is looking for that support. There's a clear difference between an advanced recovery fee versus a producer responsible. Washington has a bill signed that goes into effect January of 22, which we have a product stewardship plan with the state of Washington now. It's a pretty good model, and I work with the other states as well to discuss why I think the Washington model is going to be a good one. It's because each of the manufacturers are only responsible to recycle their own modules, and we provide a collection network and platform for them for their installers or for people to drop off solar, and the manufacturers then pay for that recycling and process. In California, the difference would be that it's a consumer-based, where, like a bottle bill, the customer pays for the recycling up front. But what they've just passed and now goes into effect in January is a hybrid of kind of a producer responsible blend and not producer responsible, but a advanced recovery blend, but the state does not pay for the recycling. And it will be more kind of just an open forum for electronic recycling. But working with the DTSC in California is a scary thing for anybody. And quite frankly, doing business in California is pretty tough. And so it's going to be interesting to see how it comes out, because they've put in their legislation some pretty ominous requirements to account for being even a collector or an aggregator of solar. And by the way, they have a lot of solar piled up in that state. They passed a law a couple of years ago requiring solar be installed in all new construction. So it's a Wild West show there in California. But I think what's most popular is the producer responsible model, similar to Washington. Although Pennsylvania, as that's where Wayne and our company met and doing a presentation with legislation there, wasn't it, Wayne? What, a couple of weeks ago?
Yeah. Our executive director and your EHS director testified.
And
yep.
So it looks like Pennsylvania is desiring to take the solar module and add it to the existing covered entities listed in their current electronic legislation. I'm not a proponent of that, because this is an electronic product that, again, is 85% glass. And as an electronic recycler, there's no incentive, there's no value, enough value, not even as much as a CRT, where a CRT device is at least 50% metals, precious metals and plastics, and there's recovery in that material, where in a solar module, outside of a little aluminum frame, there's very, very little you can recover that there is value. So I don't think it really fits there, but we'll see what happens in Pennsylvania. I guess we kind of advocated against doing that, but that's the direction they went.
Yeah, I believe our organization had the same recommendation.
Yeah, right.
So this has quite a few questions in this one. How do you define reuse? And many in the solar industry think reusing a module with or without repair. It appears you use reuse to mean use of recovered materials after disassembly and recycling down to the material level. In addition, what are the activities involved in repair, remanufacturing, and refurbishment? I've heard 3 terms used in your presentation, but I'm not sure which terms are, what activities are involved in each one of them.
Well, that's a great question, and it even confused me as I was going through my presentation. No, we actually, reuse, because we actually reuse the large percentage of the material in remanufacturing, remineralization, and making products. The reuse of the module itself, the first stage of reviewing a module, what we do first is we look at the wattage, because there's a term used in electronic recycling and reuse and ITAD of repairing computers and repairing or reusing any of those electronic components. It's called a cut line. And so we'll look at a module at its cut line based on its wattage. If it's nearly, and it keeps moving up, and a 200 watt panel anymore is almost kind of junk. So there's a cut line, but if it can be repaired, and then we look for microfractures and damage that way, that if it can be repaired and reused, that's the protocol we go through. So there is repair and reuse. If the module has broken glass, if it's cracked across the back or front, then it goes to remineralizing. If it's clean and we might see the frames bent, might have some small inclusions, then we will repair it for reuse. And that's kind of our protocol.
Okay. With regards to the process to grind down and reconstitute glass, exactly how is the glass reconstituted? Is it melted at your facilities, or is there some other process to make that happen?
The only pyromedical or using heat that we use, no, we grind it to size, and we blend it with other mineral chemistries to fit our customers' requirements for their products. It's a very interesting process. If you saw our yard, we'd look like a giant mining camp. If you came to one of our facilities, and there's just piles of different minerals, we call them. We don't really call it glass, because you can stand out in our yard and the sun shining down on these enormous piles. You could drive an excavator up. You'll see a blue pile or a green, glistening aqua green pile, and it's basically the sun exposing and showing the different mineral compositions in these different kinds of glass. And so we will make these mineral compositions, chemistry recipes for each of our customers downstream. And I hope I'm answering the question properly. And then again, when we make a certain grain size for our own process for making glass beads for that industry, which is our own product. And I guess it's a good point to say that we have a new product that we've been working on for over a decade, I was saying. And we're actually making a material that goes into concrete and replaces the binder for concrete, which is traditionally comes out of the coal industry. It's called fly ash. And this particular blend of minerals is ground to a size of smoke. I mean, it's finer than dust. And what happens with cement or concrete is, depending on the different parts of the country too, I guess in the Pacific Northwest here, we have the worst concrete in the world because it's so moist. And I'm pretty much across the northern part of the country. What this does, it's called Ironmin. It's an Ironmin product, and it goes in with the concrete, and it raises the PSI level from an average of like 65 to over 120. And why that's important is, one, it's an amazingly strong product. Secondly, it doesn't crack. Like when you're walking along the sidewalk, or you see your driveway cracks. And largely why that happens is algae, in pockets of algae, and this product actually eliminates those areas and creates an amazing product. Well, we've been independently going through testing on this for a decade, and it's now ready for launch. We're pretty excited about it, and that's just another, again, not just making mineral formulations for our downstream customers' products, but we're making our own products as well.
I think the term that's used here, Curt, is pozzolan.
Yep, it's a pozzolan effect that takes effect. Yep.
Yep. So we here we're located on the campus of Penn State, and we work a lot with our engineering professors on some research on this material. The interesting thing about glass is in larger particle sizes, it actually hurts the strength of concrete if you add to it. So there's a reaction called the alkali silica reaction that actually weakens concrete at larger sizes. But once you grind that material down to like what Curt said, down to a real small microscopic size, it actually becomes a strengthening agent. So it's really interesting chemistry and physics involved.
And we've been able to, in that chemistry, we also for years have been recycling CRT glass. We all know about that, right? Being left all over the country in piles. But we've been able to utilize the panel part of the CRT with our Ironmin product because of it's got such phenomenal minerals of strength in it. Excuse me. It's got barium and strontium and antimony and some characteristics within that panel that work very well with our new products. So we're actually making use of something that's been a major concern of for a long time. It's still amazing how the CRT still comes into the electronic recyclers in waves.
But, yeah, we're still getting them here in Pennsylvania for sure.
I could show you the scars on my hands from the years of processing it. Yeah.
So you mentioned antimony. This question has to do with the country of India has identified a potential concern with antimony in solar PV glass. Have you encountered this, and is this an issue in your processing or causing panels to be designated as a hazardous material?
No. Now, antimony, the only concern we've had or thought to have had in some ways with antimony, too much antimony enriched in our formulations, is with some of the fiberglass guys, or one of them anyway, that was claiming that antimony was wearing on their very expensive spinners, platinum spinners. Excuse me. But no, have not. There's not. We haven't seen that. Any level of concern with that.
I'm sure a lot of people know this, but there are certain metals that if it's in a waste material, it's quote unquote hazardous in the eyes of EPA. So I think there's 8, they call them the RECRA metals.
Mm-hmm.
So antimony is one of them, I believe, along with lead and chromium
and CRT glass is very high in antimony.
Yep.
But with our formulations, I mean, there's so many other minerals that the levels are not there to be concerned, from a RCRA standpoint. And each state, of course, has their different levels of concern. We've been dealing with lead glass too for years and years and years. It's crystal is heavy in lead, and we process. We've got some of the largest crystal manufacturing customers in the world. We're used to dealing with that.
Okay, these two questions are, we kind of touched on this a little bit, and this might have some proprietary information. So, they're asking how is material price? Is it per pound, per panel? Do you work regionally, locally with consolidators? Just basically, how does the logistics work with getting the glass material to your facilities?
Well, we charge by the pound, and depending upon our customer, that price per pound is dictated by volumes and just for different reasons. But our goal is that as we advance in our technologies and growth in this area, that we can continue to lower our price for the customer, and help everybody out, because the more benefits that we and our inroads of our products that we get, we're positioned to be there for the long run, in dealing with this this electronic product.
I know you have facilities all across the country, and every state's different as far as permitting. So what's a typical facility? What's it required to have as far as permit? Is it a hazardous waste classification, or residual, municipal?
Yeah, we're not a
permit by rule is typically what these facilities get designated.
Well, we're R2 certified, and we're we ISO, some permits, some of the some permits require, our standards require only from our customers, not necessarily the state. We're contracted with some of the largest waste haulers in the world, and so we're used to seeing some have different requirements than others, but pretty much all our facilities are all we deal with glass. And
do you see solar panels making it on the universal waste list?
Well, that's where they threw it in California, ironically. Yeah.
Can you explain it? Can you explain what that is, universal waste?
Well, Rick read they're in California. They added it to their universal waste, which means it's hazardous.
Okay.
For California, and requires that the solar module, if it's going to be landfilled, it has to go to a haz waste landfill. And that we're still vetting out what that means to the DTSC, and a lot of people are very leery and sticking their neck out there. A lot of the electronic recyclers there in California, and different people that are considering being a consolidator and handling end of life. So I'm not as proficient on the RCRA regulations and different our EH&S is really good at that, and probably do a better job answering that question. Which anybody that's on the phone that has that question, we can answer that. I can hook you up with Brian, who did the presentation with your group for Pennsylvania.
Right. And again, you might have touched on this question previously. Why are some panels being replaced only after 5 years instead of the anticipated 20 to 25?
Purely the increase in development of the wattage increase. I know that in a lot of sales cycles with the manufacturers, they're taking into consideration and planning, and their customers are looking at that and saying, hey, I got a 250 watt panel here 5 years ago, or 260 or 70, and now it's 400 or 480. So where's the cut line there where, I've got this electronic device that, is on a footprint of X, is producing, X amount of megawatts, and I could, in 5 years, it's twice that, right? It's an interesting time, and for that, it really is. That's why they're looking at, replacing after 5 years, because 5 years ago, like I say, a 250, 75 watt panel was just the best, and today it's doubled in 5 years. Similar, it's similar to a phone. Look what the cell phone's done in 10 years, or a computer. I mean, it wasn't long ago that you carried around a laptop that was 2 inches thick, and in less than 10 years, it went to a pad, a thin razor. Everything in the electronic world in the last 10 to 15 years is hockey sticked in technology. It's just, so there's just a natural turnover due to technology and advancement. I mean, an iPhone is a great example. I mean, look at that. What version are we on now? 12, 13,
Yep,
20?
12.
I mean, it just, you compare that to solar in its own way. And that's where we're seeing, what you'd consider a good panel being replaced. So there's a real drive for that technology. And, the battery backup, lithium battery backup systems have advanced so dramatically in the last 5, 6, 7 years, definitely for residential use, where, we can look at that in solar. 10 years ago, you'd look at solar and go, what's the return on investment there? Now it's getting up. It's really making sense. I find it interesting in this industry at solar, how you have power generators, utilities, and the residential. It's kind of and residential use is, you basically are independent. You can go kind of even off grid with, if you by energy production through solar on your home. You're not drawing off the grid from the power companies. So it's kind of an interesting dynamic in the marketplace with solar, I think.
Okay. So this is a good lead into this question, which again, you may have addressed some of the topics here. How can we claim circularity in a meaningful sense when companies are not allowing their panels to be sold on a secondhand market for fear of competition with their new products? Breaking panels down into their constituent parts and making new panels seems unlikely to be more efficient than using those 5-year-old panels for another 20 years.
Yeah.
There's a lot in
what
there.
What can I say? It's technology. Can't stop progress.
Right.
The circular economy play for us is that I'm going to take that device, I'm going to process it back into a raw material for manufacturing. It's not a, for me, it's a product that, again, just fits our what we do, and from a circular economy play. And that's why I worked so hard. I said, we're producing a mineral composition for the glass float plant that we're working with to make new plate glass that is made, that is solar glass. And I don't know how much more I can complete the circular play on that than,
I guess the point is, even though it's not as high on the hierarchy, it's still being handled correctly. It's not going to a landfill.
No.
So you're.
No. Yeah.
Okay.
It's coming back into another product, whether it's a solar panel or another product,
Okay. So we have one more question here. So how do you recommend building infrastructure? Okay, I'm sorry. So another question just popped up. How do you recommend building infrastructure in the mountains and plains region of the U.S. for more comprehensive solar panel recycling?
Yeah, it's a case of volume. That's a pretty, it's a good question. Transportation, it's just people live in regions where it's less populated, but you might have, South Dakota or Nebraska or someplace where, you have opportunities to have large installations of solar. And I've dealt with them. Excuse me. It's just a little bit higher transportation costs to get to one of our facilities, so it's a little more expense into recycling, but it's not that much of a challenge, from a transportation standpoint.
Okay. All right, so we're going to wrap it up here. So again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thank you again for joining us. We hope you'll join us for next month's webinar, and please visit the NRC or RMC websites for schedule updates. And again, thank you, Curt, for a great presentation and answering these questions. Really good questions from the audience. I really appreciate that. So thanks again. Have a great rest of the day, everybody, and stay safe.